Cambridge AS Computer Science, Chapter 2, Communication, Part 4, IP Addressing. IP addressing is a very important and interesting topic. IP comes from Internet Protocol. IP addressing is Internet Protocol addressing. We discussed previously about MAC addressing or the MAC address. A MAC address is permanent. A MAC address is created by the manufacturer, and we call it hardwired into the device or hardwired into the device network interface card. Okay? When we are talking about a switch or a local area network, we will be talking about a MAC address. However, when we talk about wide area networks, specifically talking about the internet, every device on the internet must have its own IP address. And that IP address must be unique, must not be repeated on the same network. Okay? I will tell you variation about this in that IP addresses should be unique. Definitely should be unique on the same network. However, we may have separate networks. Actually, we have something called public IP address that is published and public on the internet, and we have private IP address that is used within each user's home. Then we have a private IP address. And then we also have network address translation that translates a public IP address into a private IP address and the reverse. Why do we have to study this? We also have to study static IP address and dynamic IP address. We also have to study IP address version 4 and IP address version 6. Let us start the story. When they first invented the IP address, they thought at that time 32 bits is enough to have as many different IP addresses as we need. So they invented IP, and that time was called IP version 4. And it used to consist, and it still consists of 32 bits. Okay? And 2 to the power of 32 is giving you 4 billion different IP addresses. That is quite a lot. However, the population on Earth now is about 7 billion. And everyone needs or wishes to use 2 or 3 different IP addresses. So now we consider 32 bits and we consider IP version 4 insufficient. We think that it is insufficient. It's not providing us with enough unique IP addresses. Then they started to invent what is called dynamic IP address. When you turn off your computer, your IP address will be assigned to somebody else. Why? Because there aren't enough IP addresses. So now we will also need to consider what is called static IP address and dynamic IP address. Dynamic IP address, when you turn off your computer, your IP address will be assigned to somebody else to use it until you come back, and we look for you. Then the network looks for you for something that is available. So your IP address may change. This is what is called dynamic IP address. If you want a static IP address that never changes, even if you turn off your computer and turn it on again, you want a static IP address, this is going to be a little bit more expensive. It will cost you a little bit more. And definitely, servers need a static IP address. For example, the web server for Amazon.com needs a static IP address. The web server for Amazon.com needs a static IP address because that IP address will be listed in the domain name server DNS, and you don't want it to change. Okay? Okay, so servers need a static IP address. Okay, let us tell more stories. We have what is called public IP address and private IP address. You may have a local area network in your home. Maybe wireless local area network connected using Wi-Fi. All computers in your home will be using what is called private IP addresses that are not publicly or publicly visible on the internet. Okay, all of your house will be accessing the internet through only one real public IP address, and that IP address will be assigned to the router. And the router has what is called the NAT. NAT stands for Network Address Translation. It translates between your public IP address and your private IP address. This saves a lot of IP addresses because private IP addresses may repeat in your home. There is a special domain that is used for private IP addresses that can repeat from one home to another because they are separate networks. All what I have been talking about relates to IP version 4. Recently, they developed IP version 6 that is 128 bits, that is so large. And then you don't need public IP address and private IP address. Everyone becomes public because there are 2 to the power of 128 bit, because you have 128 bit in IP version 6. Okay, 2 to the power of 128. It's such a huge number that will never be consumed in the near future. Things change, but I think 128 bit, 2 to the power of 128 is such a huge number. Okay? Okay, let us go and read what is written in my notes. I told plenty of the stories, but not all of them. So, IP addressing, the functioning of the internet is based on the implementation of the TCP/IP protocol suite. In the A level, you will study more details about the TCP/IP protocol suite. One aspect of this TCP/IP protocol suite is IP addressing, because IP comes from Internet Protocol, which is used to define from where and to where data is being transmitted. You already know that. You already know that data is split into packets, and every packet will have a packet header. In the packet header, there will be IP address of the source and IP address of the destination. These are the addresses we are talking about. The IP address is unique, must not repeat in the same network. Otherwise, conflict will occur. The IP address should match the network it is on. Actually, the IP address is split into 2 parts. Any IP address is split into 2 parts. The part on the left, the first part is the net ID, is the ID of the network itself. And then follows the host IP, the IP of the device within that network. So part of the IP address is the address of the network itself. So the IP address must match the network you are on. Here we have class A, where only 1 byte is net ID and 3 bytes as host ID. Class B, we have 2 bytes net ID, 3 bytes host ID. And class C, where you have 3 bytes net ID and 4 byte host ID. We will come to this. We will come to this very soon, inshallah. Okay? So, once there was a question that said, what is the purpose of an IP address? The IP address gives each device on a network an identifier. What is an identifier? An address, a name, a location. The IP address is used to look up a device on a network. Each address is unique within the network. The IP address allows a device to send data to the correct destination, a specific device. You specify a device using its IP address. Okay, IP addressing, IP version 4 addressing. We have been talking a lot about IP address version 4. In the first place, they consist of 32 bits divided into 4 groups. Every group is 8 bits. So every group, the value of the number in each group must never exceed 255 because a group is represented as 8 bits. They are shown in denary. IP address version 4 are shown in denary. IP address version 6 are shown in hexadecimal. Okay, you have to study all these, and the questions ask you about this. Currently, the internet functions with IP version 4. So currently, we wish to move to IP version 6. However, all the infrastructure is now following IP version 4, and it takes a lot of time and a lot of money to move totally towards IP version 6. Let us study all we can about IP version 4 because it is the most widely used till now. Okay, the IP addressing scheme is based on 32 bits, that is 4 bytes, used to define an IP address. The 32 bits allow 2 to the power of 32 different addresses, which is approximately 4 billion addresses. IP version 4 address is 32 bits long. Hierarchical address. What is meant by hierarchical? It is split into parts. Part of it is the net ID. And the other part of it, you go first to the level, the top level, that is the net ID, and then you go down to the host with the host ID. So there is a kind of hierarchy like this. Okay? A format of IP version 4. Definitely you have to know it very well. IP address is composed of 4 denary or hexadecimal integer. Sometimes they are written in hexadecimal, but popularly IP version 4 is written in denary. Okay, each in the range 0 to 255 because they are 4 groups. Every group is 8 bits. The biggest value that can be stored in an 8-bit is 255. So every group can only range from 0 to up to 255. Denary or 00 to FF in hexadecimal. If it is represented in hexadecimal, it is very rare to represent IP version 4 in hexadecimal. However, it may show in exams like this. خلاص? Okay. IP address consists of 4 numbers separated by full stops. For example, 109 full stop, 108 full stop, 158 full stop, 1. IP is separated into net ID and host ID. The first 1 or 2 or 3 groups, depending on whether it is class A or class B or class C. We will be studying these classes very soon. So an IP address is separated into 2 parts. The first on the left, the first part on the left is the net ID. Maybe 1 group, maybe 2 groups net ID, and the rest is host ID. Okay, so IP version 4 is split into network ID and host ID. As you can see, IP version 4 address in dotted decimal notation, 172, and this is something 8 bits, dot 16, and this is something 8 bits in binary, and dot 254, Maximum, it could go up to 255. Cannot exceed this because you have 8 bits for every group. Dot 1, for example. So every 8 bits is a byte, and you have 32 bits, that is 4 bytes. Example, quite often in exam, they ask you whether this is a valid IP address or not valid IP address. Okay? These are exam questions. So example, IP version 4 address 12.258. That 258 is invalid because it is outside the acceptable range from 0 up to 255 because it only stored in 8 bits. So the IP address 12.258.3 is invalid as 258 is too large. Also, there are only 4 groups. There are only 3 groups. There are only 3 groups. One group is missing, and as only 3 groups of numbers are given. So this is invalid. Another example. 3A is okay. It's okay to have IP version 4 represented in hexa. So 3A is valid. 2.1 is valid. However, 2H is invalid because H is not a valid hexadecimal digit. 299 invalid. 299 is not in the correct range. 192.2.1.0 is valid as it consists of 4 numbers in the range 0 to 255 separated by full stops. Okay. Another example. 3.2a.6aa. This is invalid. This is in hexadecimal. However, 6AA is too big. B is too big. So this is invalid. 2.0.255.1 is denary and is valid. 6.0.257 is denary as invalid because 257 is out of range. 0A, 7, 8, 5, 4J, there is nothing called J in hexa. This is invalid because J is not a valid digit. Okay. Next, we discuss IP classes. An IP version 4 would split into 2 parts, not necessarily equal parts. We have 3 classes. If you have class A, then the first byte, the first 8 bits is the net ID, and the remaining 3 bytes, that is the remaining 24 bits, is the host ID. So the net ID is when it is class A. The IP address will split into two halves. When it is class A, the first byte is the net ID, the remaining is the host ID. The net ID represents the network, the host ID represents the computer on that network. When it is class B, is divided into 2 equal halves. The first 2 bytes is the net ID, the last 2 bytes is the host ID. When it is class C, is split in such that the first 3 bytes is the net ID, and the remaining byte, the fourth, is the host ID. Okay? So this is class A, class B. It depends. If you have a small network, you only need 8 bits as a host ID, and the remaining could be net ID. Okay? And there is a way to tell if that IP address is class A or class B, or class C. So in IP address, the IP address is separated into network ID and host ID, as this diagram. The network ID is the ID common to all computers on a network, or is the ID of the network itself. The host ID is the unique ID of a particular computer on a network. Most IP addresses fall into one of the three classes: Class A, Class B, and Class C, as you can see. From the IP address itself, there is a way to tell if this IP address belongs to Class A, or to Class B, or to Class C, because it is necessary to interpret which bits or bytes represent the net ID and which bytes or bits represent the host ID. You take the first byte on the left and convert it into denary. I'm sorry, you take the first byte on the left and convert it into binary. Here it says if the 32 bits start with 0, yeah, it's simpler than that. You take the byte on the left and convert it into binary. If it starts with 0, then it is Class A. If it starts with 1, 0, then it is Class B. If it starts with 1, 1, 0, then it is Class C. Okay? So you need only to convert the byte on the left, the group on the left. You don't need to convert the whole 32 bits, just the byte on the left. The allocated address is based on the concept of different classes of network. These are three classes. Okay? Okay? So, if the class identifier starts on the left with 0, then it is Class A. The remaining 7 bits become the net ID, and the other 24 bits is the host ID. Okay? As this diagram. But we say 7 because the 0 is outside the net ID. You have here 8. One of them is taken as the identifier. If it starts with 1, 0, then these should be 16. However, 2 of them are taken, so the remaining 14 is the net ID, and that other 16 is the host ID. If it starts with 1, 1, 0, it is Class C. You only have 8 bits for host ID, and here 21, they should have been 24. But these 3, 21 plus 3 is 24. These represent the net ID. Okay? In a class A address, the first byte represent the net ID. The remaining 3 bytes represent the host ID. In Class B address, the first 2 bytes represent the net ID. The remaining 2 bytes represent the host ID. In Class C address, the first 3 bytes represent the network ID, and the remaining byte represents the host ID. That was an example. For the address 205, we want to know which part is the host ID and which part is the net ID. You take the 205 and convert it into binary. 205 converts into 110 01101. if you notice that this is the identifier for class C, as it starts with 110, so it is class C. The first 3 bytes, these are the net ID, and this is the host ID. The first 3 bytes is the network ID, and this one, and the remaining byte is the host ID, this one. Okay? Okay. This leads us to subnetting. Subnetting is also something very important, because when you have this is for example net ID. We group computers into networks, and networks cannot talk to each other on different network. Computers on one network cannot talk to other computers on another network unless there is a gateway or a router between them. And this improves security, and this enhances the reusability of IP addresses. So, because this is a network, so computers belonging to different network ID are on different networks, and they cannot talk to each other unless there is a router in between them. And this is called subnetting. On the internet, all of the allocated IP addresses have a net ID pointing to the router. So the net ID points to the router controlling that network. The router then has to interpret the host ID inside of the IP address. The first part is the net ID, and the second part is the host ID. The net ID takes data to the router. The router then takes the host ID and then forwards data to the required or specific compute. Okay? In a subnetwork, IP address is made up of network ID and host ID. And this is common. We already told that. Each device in a subnetwork has the same network ID. Each subnetwork has a different network ID. So if they have this part in common, 2 IP addresses, they have the same net ID in common, they belong to the same subnet, and they can talk freely to each other. If 2 different IP addresses each belong to a different network ID, then they are on 2 different subnets, and they cannot talk to each other unless there is a router to enable this. This enhances security. This enhances security. Okay? Each device in a subnetwork has the same network ID. Each subnetwork has a different network ID. Every device in each subnetwork has different host ID, but the same network ID. The host ID uniquely identifies the device within a network. Subnetting reduces the amount of traffic in a network and improves the network speed as data stays in its subnet, so does not travel so far. With the use of subnetting, you have less traffic because only computers that belong to the same subnet may talk. Subnetting improves network security, as not all devices can access all areas of the network. Subnetting allows for easier maintenance because only one subnetwork may need to be taken down or changing while the rest of the network continues. So if you are doing maintenance, you take one subnetwork out of service until you fix. Benefits of using subnetting: improves security, improves performance, reduces congestions, allow extension of the network and devices attached, aids day-to-day management. Okay, let us go into more and more examples. I think very soon we will finish when we talk about IP version 6 as well. Let us go through everything in detail, because a subnet mask is used when subnetting a LAN. Two devices on a LAN are located in different subnetwork. The IP addresses are and corresponding subnet mask as shown. What is that subnet mask? The subnet mask is another way of showing which bits or bytes belong to the net ID and which bits or bytes belong to the host ID. If you have here 255.0.0.0.0.0, 255 is 8 ones, and these are all zeros. The ones represent the net ID. So here you have the 10 as the net ID. Why? Because here you have here all ones, and all the ones point to the net ID. Okay, so 255 converts into all ones, and all these zeros convert to zeros. The 255 converts to ones, and these are the ones that point to the net ID. Here you have 255, 255, 255. These all convert to ones, like this. So these are the net ID, and the remaining is the host ID. The IP address is split into two parts. We know this very well. The network ID and the host ID. I am coloring the network ID in blue. After converting the subnet mask into binary, like this, the part of the IP address corresponds to the ones part of the subnet mask is the network ID. The remaining that are in black correspond to the host ID. So subnet mask shows how to group them into net ID. From the table above, network ID for the device IP, this one, the network ID is 10. The network ID is 10, and the host ID is the remaining ones. Okay, so the network ID is 10, the host ID is that one. For the network ID for the device IP address, this one, all of this is the net ID, and the remaining is the host ID. Why? Because you have all these ones. Actually, these are very recent exam questions. Pay close attention to them. I am discussing with you very recent exam questions, so that when you go to the classified, you will find them already, you know about them, you can just resolve them again. Okay? Okay, enough about host ID and net ID and about subnetting and subnet mask and classes, class A, B, and C. Let us go into more easier topics. Probably the following topics you already have ideas about from the O-level. What is dynamic IP address? A dynamic IP address changes every time you connect to the network. So if you turn off your computer, your IP address will be assigned to somebody else. And when you turn on your computer, there is something called DHCP, Dynamic Host Configuration Protocol. okay, looks for a free IP address and gives it to you. Probably a one different than the one you have been using before. So dynamic IP address changes. A static IP address do not change. When you turn on your computer and you turn it off, or you turn it off and turn it on again, you reserve the same IP address is reserved for you, probably for an extra cost. Why would you need a static IP address? If you are a browser, or if you are using a browser, it's okay to live with dynamic IP address. However, if you have a server, a web server, you need a static IP address to be listed in the DNS domain name service. So the domain name www.amazon.com always goes to the same static IP address. Okay? Web servers need a static IP address. Static IP address do not change, whereas dynamic IP address does change. With a static IP address, the DNS server does not need updating. I don't like to have dynamic IP address with DNS. Okay? Okay. What is public IP address? Public IP address is an address that is publicly accessible through the internet. This is different than private IP address that is only accessible within your local area network. So probably at home, you have a local area network, or maybe wireless local area network. You have a local area network or a wireless local area network. In your home, you will be using private IP address. In that range, these private IP address ranges are reserved for private IP address. There is one range in class A, and this is the range. And this is the subnet mask, as you can see, 255. That means only the 10 is the net ID. And this is in class B, 2555. So as you can see, this is class B. However, maybe you need to be familiar with this. These three ranges are reserved for private IP addresses and are not allowed to be used on the internet, or not allowed to be used as public IP addresses, to isolate them from public use and only use them privately. In your home, you will have a router, and that router functions as network address translation, NAT. That router has one public IP address accessing all the internet for all members of your home using that one common public IP address. Your private IP addresses are local inside your home and never used outside. Probably that class 192.198.0.0, okay? This is the range, class C private IP address range. Probably inside your home, any device in your home will be something 192.168.0.1.0.2. Probably this is the IP address of the router itself in your home. Your router will have two IP addresses, one belonging to the private IP range and one belonging to the public IP range, and it keeps converting to allow the whole of your home network to connect to the internet. Okay, so this is private IP address is more secure. Using a private IP address is more secure because your IP address is not public on the internet. So attacks will not go directly to your device. Attacks may go to your router, and the router is protected by a firewall. So why do we have private IP addresses in the first place? Because IP version 4 is insufficient. Okay? Private addresses cannot be reached across the internet. Private addresses are assigned by the network of the router of the network concerned. Private addresses are unique within their network but can be duplicated. So my private IP address in my home may duplicate with another private IP address in your home, but as our homes are separate, no conflict will occur. Okay? The IP address from the private IP address never assigned as public. These ranges are never assigned as public. Once there was a question that says comparison. It said compare between public IP and private IP. Public address can be reached across the internet. Private address can only be reached internally and cannot be reached across the internet. Network address translation NAT. You need in your router, there is something called network address translation that translates between public IP address and private IP address. A private IP address is more secure than a public IP address. Public IP address are provided by the ISP, Internet Service Provider, and assigned by Internet Network Information Center, InterNIC. This is an organization that controls public IP addresses. Private addresses are assigned by the network. There is something called DHCP, Dynamic Host Configuration Protocol, that finds any empty IP address and sends it to you. Public addresses are unique on the internet. Private addresses are unique within their network, but can duplicate with other discrete networks. And these are the ranges that form private IP address. Know them. No need to memorize them very hard. Okay, more example. The address can be reached over the internet. This is public. More secure. This is private. Address can only be accessed through the same LAN. This is private. That belong to the same network, private network. Okay. Address can duplicate in different network. This is private. It is only visible to devices within the local area network. This is private address. A new one is reallocated each time a device connects to the internet. This is dynamic. It is visible to any device on the internet. This is public. It does not change each time. This is static. And this is network address translation. You need network address translation to translate the public IP address into a private IP address. And this is that NAT box. That NAT box would be typical inside a router. The NAT box has one IP address. The NAT box has two IP addresses. One belonging to the public domain and one belonging to the private domain. Actually, I was telling you that that NAT box is your router, or precisely that NAT box is inside your router. And these are the ranges of private IP address. Okay, 192.168.2.1 is an example of private IP address. So you have to study these ranges. Assigned by the internet service provider, this is public. Because the internet service provider provides the IP address that will be stored in your router, public IP address. IP address cannot be duplicated in different networks. This is public. Network address translation NAT is necessary for private. The last thing to say, and it will not take long, is IP version 6. IP version 6 is totally different. However, we only need to study its format. We only need to study its format. IP version 6, there must soon be a migration to IP version 6. IP version 6 uses 128-bit addressing scheme, allowing 2 to the power of 128 different addresses. This is a huge number. There is a need for IP version 6 addressing, as the number of IP addresses will exceed the number available for IP version 4. The format of an IP version 6 address is set of 8 numbers. You have 8 groups: 1, 2, 3, 4, 5, 6, 7, 8. 8 groups separated by colons. And every group is 4 digits hexadecimal. 4 by 4, this is 16. Each group is 16-bit. And you have 8 of these. 8 by 16, this is 128 bits. خلاص, each number is 4 hexadecimal digits separated by colons. For example, this. However, because that IP version 6 address is very long, sometimes we need abbreviation. For example, if you have 2 groups of zeros like this, you substitute them with colon. You may put only once in your IP address, double colon to represent any number of missing zeros. But use this only once. So this double colon, this double colon, because they are incomplete, fill them all with zeros. But only use this once, because otherwise you don't know how many to fill here or there. So this is a full address. This is a valid address. However, this colon is represented by zeros. Here, the 2 leading zeros are omitted. And this is IP version 4 used within IP version 6. You put double colon, and then you specify an IP address version 4 used in IP version 6. Example, and then we are done. An IP address has been entered as 15E5 colon 5L. There is nothing L. L is not hexadecimal. And then here you cannot have 2 of these. You may only have 1 of these, because you will be filling all missing digits with zeros. You cannot have twice of them, because you don't know what to fill. So this address is invalid, as L is not a valid hexadecimal number, and only 1 double colon is allowed. This double colon is only allowed once. Example, this valid. This one valid as an IP address version 4 using IP address version 6. This valid as this can expand to as many zeros as you wish. This is invalid because you cannot have twice of this. This is valid. This is valid as it is IP version 4 used within IP version 6. This is valid because the double colon would expand and fill it with all necessary zeros. This is invalid because you cannot use the double colon twice. The last thing to say, use hexadecimal notation, IP version 4 and IP version 6. Each group of digits is a number between 0 and 65,536. This is only in IP version 6 because they are 16 bits. Each group is 16 bits. Consists of 4 groups of digits. This is IP version 4. Uses double colons. Only IP version 4 may use double colon. The total length 32 bits. This is IP version 4. This is all what you need to know about IP version 6, the format, whether this is valid or invalid, and then it consists of 128 bits, giving much bigger space for storing different IP addresses. Thank you very much for your attention. Please do all the exercises in the classifier.